Good afternoon, lecturers. Welcome to today's webinar, Programming and Robotics, Level 2 and Level 3. My name is Gyan Krishna from Macmillan Chopin Publishers. We are committed to supporting lecturers and making the teaching of this new course in IT as easy as possible for you. Please note that today's session is being recorded, and we will share the recording so that you may go through the presentation in your own time. A brief background on our authors and presenters for today. They are Sam Sasti and Shailendra Sasti. They are provincial and college world skills SA experts in IT software solutions for business skills. Very experienced TVET lecturers with more than 37 years experience between them. They are also seasoned national markers for IT subjects, including CM and IM. Any questions you may have, please make use of either the chat or the question box to post these, and the authors and presenters will tackle this right at the end. So I'd like to hand over to our first presenter this afternoon, and that is Sam Sasti. Over to you, Sam.
Thank you, Gyan. Good afternoon, colleagues, and welcome to this presentation. It's our first webinar for Programming and Robotics by Macmillan and TVET. So as Gyan has put this really well, our webinar today is focusing on programming and robotics. So for today, we're going to be explaining the new curriculum, going through our textbooks for level 2 and level 3, and also how to teach the programming and robotics curriculum. So I'm not certain who exactly is attending this webinar, but there are colleges that have started or piloted this particular stream in IT this year, and then we do know there's a lot more colleges that are joining us again next year for the first time. So today's webinar is especially for those who are planning to do programming and robotics next year in 2024. So it's to give you an overview of what the syllabus or curriculum is like for level 2, and also what to expect in level 3. And for those who are already doing level 2 this year, it's to give you an idea as to what to now expect in level 3 itself. So our webinar for today will focus on the programming aspects, as well as we also have Mr. Mogotsi, who will be joining us to also give a brief overview of the electronic and digital concepts for robotics, that particular syllabus. So next week, we also have another webinar scheduled. So it was supposed to be a repetition of what we're doing today, but there is a lot of content to cover, and we really want to be able to assist all lecturers, especially those doing it for the first time. So next week, we can do a very quick overview of what was covered today. And then we also want to go about how to prepare for the level 2 examinations for those who are doing the course this year. How to prepare students for level 2 examinations, and then also introduce the concepts of simulators and how it's used in the robotics fundamentals subject. And Sam, then for future...
Hi, Sam. Sorry
yes.
to interrupt. You mentioned that next week's webinar is not a repeat of today, so it'll be different content that needs to be covered. Is that correct?
Yes.
Yeah, you're right.
Yes.
So I think
yes.
those that in attendance today, they need to register for next week's session as well, if they would like to attend
yes.
the follow-up session.
Yes.
Yeah.
Yes. That would be best.
All right.
Yes. Yeah. So going on, we also need to cover the use of simulators. From experience, we will tell you about our experience and what it was like this year, and how important it is for students to be able to make use of simulators, or the different types of simulators that are out there. And then we do have future trainings planned which Shailendra has suggested that maybe we could conduct these in person, or if that's not possible, we can also look at online training via our webinars. Okay, so our agenda for today would be to review this new curriculum for programming level 2 and level 3, discussing the effects of the changes on lecturers and students. So most of us have been used to teaching the old NCV IT and computer science courses, which was systems development. So that is still very much alive, and we have a lot of support for those particular streams. So it's now something new that people are being exposed to now, this whole concept of robotics and the Internet of Things. And a lot of people aren't aware as to what exactly is out there. Some of the challenges that we faced this year, many colleges faced this year, was in terms of resources. We weren't able to procure Raspberry Pis, for example, on time to conduct practicals. Hence, the idea of using simulators became really important. So again, that's something that we will discuss later on as well. So also in here is going to be how to teach the new curriculum. Very importantly, to introduce you to features and tools that are provided in our textbooks to be able to assist you as lecturers and also your students. And we will end off the session by looking at electronics and digital concepts for robotics, level 2 and level 3. Okay, so I see I have Shailendra Sasti here. Shailendra, do you want to step in?
Hi, Samantha. Thank you. Hi, everyone. Sorry, I had some technical issues. Okay, so just looking at the quick snapshot of the programming subject. So we actually trying to do, we're actually very ambitious in this presentation today because what we were trying to do, we try and cover all three of the main subjects in some way or form, but the core focus area being the programming subject. So we'll see how far we'll go. We do have another webinar planned next week as well. So what we don't finish this week, we'll finish up in the next week's webinar. So it's very important that you guys register for both. We also want to use next week's webinar as well as an opportunity to guide the lecturers and with regards to planning for the examinations. Okay, so let's have a quick snapshot of this of the programming module. The programming module is a very important subject in this programming and robotics program itself, right? So you all know that there are four. Actually, there are three compulsory subjects to choose, and the fourth one, the college gets to choose which one is more convenient for you all. But the programming module is basically a subject that is interlinked between the electronics and also the robotics, right? So one would argue that the robotics has components of all three, but if you look at the programming, is absolutely crucial because it covers introduction to computers, computer literacy, goes into programming, goes into GPIO programming, covers a bit of electronics. So it's a very critical part for the course. So why I have the snapshot out here, this is very important because when we had sessions with lecturers this year, the lack of understanding of how to teach the subject because it's very new, and we are used, especially those with IT and computer science programming lectures, and if you've done it for quite some time, you understand what learners need to cover in level 2, what they need to cover in level 3, what they need to cover in level 4. But this course is very unique. So in essence, what we will normally have in a level 2 module is actually not the complete course. We actually have what you normally find in level 2, 3, and 4, all combined into a level 2 module. So this snapshot is so important to guide us. So these are basically the cognitive learning outcomes that a student needs to be able to accomplish. So level 2, what must a student be able to basically master? These are the concepts that a student must be able to master. And if you look at it, you can see these are quite simple stuff. Introduction to hardware and software, principles of problem solving, because that's critical to IT and programming, visual programming, because we make use of visual programming in a big way throughout the course, levels 2, 3, and 4. Python programming, because that's the language to be choosing in level 2. Data types and decorations, basic arithmetic operations, input output, conditional structures, iteration structures. Now note it stops here at iteration structures, right? But if we have a look at the actual curriculum document, it goes on beyond that. It goes into functions, into strings, it goes into arrays, it goes into a bit of OOP as well, text files. Now you ask yourself the question, why? Why is that the case? And then if you look at the level 3 cognitive growth, you can see here, it talks about reinforcing the problem solving principles, debugging, reinforcing arithmetic, condition structures, validations, function strings, data structures. Now you can see here, these two, if you've done IT computer science level 2 and level 3, you'll notice this is quite familiar to you, whether although the language they covered is Visual Basic, but you'll notice that the outcomes are very much similar. So why in this course for programming and robotics, why is the programming module gone beyond what we see here as a cognitive growth? That is because of the requirements of doing GPIO programming, right? So to be able to work with the Raspberry Pi is what we're looking at in level 2. The student's going to have to know stuff that's beyond iteration structures. They have to know how to use functions. They have to know how to use arrays. And by using a visual programming language like Scratch as well, it basically introduces these higher level concepts. When I say higher level, higher than level 2, what would normally be covered in level 2. So it introduces those concepts to them in an easier way that they'll be able to understand. So these students will have to be able to go a bit beyond the normal, what we call cognitive level growth for the student, a programming student, for this course. And that's what makes it tricky, right? So as lecturers, when we are teaching, we need to understand that the student are only really meant to master up to this point here. Once you're going beyond that, and this is what's needed for the course now, right? Don't get confused. That's needed for the course. Once we go beyond that, the students just need to have a basic understanding, not to master it, but a basic understanding just to be for them to be able to do the practical components. Because once they use the robot and they see it functioning, they will start to be able to work with arrays and functions a bit more meaningful way. But without mastering it, they're not yet at that level to master. They will start to master the concept of functions and so forth in level 3. So when you are testing and so forth and preparing for the exams, you need to bear in mind the type of questions that you're going to be preparing them for, that they are not yet at the mastering level for concepts such as functions and arrays and files and so forth. So that is something we need to bear in mind, and that's something you also need to emphasize to your students when you teach them. So what do they master? These are the components that they're going to have to master. They must master this in level 2. These are the concepts they must master in level 3, and these are the concepts they must master in level 4. And as you go across the different levels, level 2, level 3, level 4, you notice even the languages changes, right? The programming languages change. We also change the IDEs. So as IT students, what we are doing is we are basically empowering them to upskill themselves to be empowered in various tool sets that's needed in the industry. So when they go into an industry, doesn't matter which company they work in for, they'll find, hey, hold on a second, we're working with Python, I'm comfortable with Python. We work with C++, I'm comfortable with C++. We're working with a visual programming language similar to MBlock in industry. Scratch is not really used, but they use a language that's similar to MBlock, and it'll be, oh, fine, then I've been exposed to MBlock. So that is the reason behind this with the curriculum designer, why they've actually made some of these things. So these are the concepts that we must understand. If we understand this, then when we're teaching, we'll know where to put the emphasis on and where we need to understand. The students need to have a basic understanding. If you're going to go to in-depth detail in arrays, then you are basically gonna lose the student, because arrays can get very, very complicated. Okay, so that is the basic outcome I wanted to explain here, and this is taken. This figure you'll find here is taken directly from your curriculum document. So you'll go, when you go through your curriculum document, you'll see it there, and they talk about the cognitive growth as well. So it has to. So that's the reason why we're bringing this up, to make sure that everyone is clear from the outset, and that'll help you in the teaching practices. Now the other thing is that we need to bring into consideration here is regarding your hours. So this curriculum uses 110 notional hours. Well, as NCV programs, we know that's the hours that we basically be using, right? So we're quite comfortable as NCV lecturers with this. So you're looking at your contact time, going to be 56 hours, 20 hours going to be your internal assessments. That's in covering everything. It's covering your PANTs, it's covering your tests, it's covering your ISATs, it's covering your trial exams. But another component that is something that we do not focus a lot on is 34 hours of self-study. And this is something that hopefully we can unpack a bit more when we have a physical training session. What do we mean by the 56 hours of contact, and what do we mean by the 34 hours of self-study? Self-study here in this case doesn't mean now you need to go and shouldn't need to go at home and continue. They don't have Raspberry Pis at home. They don't have Arduino boards at home. So what is this self-study? What does it actually entail? So when you are teaching the course uh, at the college, 56 hours is going to be where you are demonstrating, you are unpacking the concept, you're demonstrating the concept, the students see it, then they need to practice the concept. When they are practicing the concept, and in our book, we make use of various types of activities, very, very specifically designed to help with the cognitive learning process. So we have an activity called a try it yourself. The try it yourself is basically a step-by-step activity where the student will now must be able to attempt the activity on their own. That is self-study now, right? That is the self-study component. So after you've unpacked the concept, unpacked the example, demonstrated to them, show them how it works, then there's now an activity where the students can now follow on their own and attempt it by themselves, or using a textbook which is done step by step with screenshots and steps explained there in the notes, so they can be able to do their self-study component. That's so important because they need to be able to um, basically reinforce the learning process by being able to do it on their own. Okay, so that is the important part that we wanted to cover. So we can move to the next slide there, Sam. Okay, so we talk about the languages. So like I did mention before, we're going to be covering various languages in this course. So in level 2, they're going to be making use of Scratch on the visual side, on visual programming. They also be making use of Python, which is going to be your command-based programming. And the reason for that is because of the type of GPIO programming that they're going to be doing. So in level 2, they'll be making use of the Raspberry Pi. So the Raspberry Pi requires you to use Python, and that's the reason why we're using Python there. In level 3, we'll be making use of the Arduino board, and we do GPI programming with Arduino, and for that we'll be making use of MBlock, and the command-based programming language for Arduino is C++. Well, it's a version of C++. It's a simplified version of C++. So, but you'll notice that in this subject, in the programming subject, we don't do the simplified version. We do C++ proper. So these guys will be able to work with C++ in any other environment, but when you do the GPI programming part, it's a lot more simpler. It's a bit lightweight. Okay, and then in level 4, they go back to Python again and a bit more advanced programming there. Okay, we can move on to the next slide.
Okay. So our next slide is on assessments. Okay, so these are, yes. Sorry?
Okay, no, that's fine.
Yeah. All right, so assessments, this screenshot is taken from the DHET's ICAS guidelines. We follow the exact same guidelines when it comes to our assessments for the new subjects, that these new vocational subjects. So it's still a test in term 1 and a practical assignment also in term 1. The weightings are still 10% and 25%. In term 2, we do our second pack, and then we also have another test. Weightings are shown. And then term 3 is where we have our internal examinations. So this is a programming subject, so we are used to having 2 papers for this particular subject, where paper 1's theory and paper 2 is programming, which is the practical. When we do discuss the other subjects, you would also now see that even robotics fundamentals and electronic and digital concepts for robotics, those subjects are also having 2 papers each for the internal examination and for the final examination. So that's a discussion that we will have when it comes to examinations, which might be in our next session. So that's in terms of our ICAS tasks that need to be completed for the year. In terms of the examinations, what is not here is the ISAT. So currently the ISAT is a combined ISAT consisting of the programming, the robotics, and the electronics and digital concepts. So all 3 of those subjects are combined to generate 1 ISAT mark, which will be used for the 3 of those subjects. So in terms of the exam breakdown or examinations, again, this is taken from the curriculum document. So the levels are indicated there on the top. It's roughly the same. In level 2, paper 1 theories about 100 marks. And then our practicals also about 100 marks. And then the time frames are given to you. 2 hours generally for a theory paper, 3.5 to 4 hours for your practical paper. In terms of the topic distributions as well, this is also in your documents. So paper 1, the weightings are shown from the different topics. That gives you an idea as to what to expect in the question paper. The same for the practical as well. The focus for practical will be Scratch programming, will be programming in Python using Turtle, which is a very nice way of introducing students to Python. And then 50%, half of the paper is on solution development, which again is Python, the Python programming language. Right, so here we are on the benefits of using the programming and robotics range of books. So number 1, very important on that list, free lecture training webinars are provided. So webinars will be scheduled more regularly and it is free. The student book contains a lot of content. In terms of what is actually important to the students, so you would find that our textbook is not as thick as maybe some of the others you would have seen, because we understand exactly how much time lecturers have to complete the syllabus. And so we try to ensure that we put in as much content, but in an easy to understand manner, and enough activities like Shalendra spoke about. We have what we call try it yourself activities, which go step by step with the student. And then we also have what we call test yourself activities and summative assessments. So those are activities now where students can test their knowledge. And then the summative assessments are more aligned towards what you can expect in an examination paper or a test or your trial exams and so on. In terms of lecturer support, please note we do have designated email address. If you haven't used our personal ones, this is also available to you. It's safety.textbooks@gmail.com. So whenever lecturers have any queries, they just email us on that, and then we are very good with our responses, and we will try to assist you wherever we can. In terms of lecturer support, so with the lecturer guides, I think you got maybe a memory stick, not a CD. So we have provided detailed lesson plans. We have given you a complete facilitation plan as well. We have also included PowerPoint slides that will assist you when it comes to teaching in class, and it follows the content that's in our books as well. There's solutions for all activities. Sample exam question papers, we will include those on our memory sticks that we give you with the LGs. The curriculum designers have created sample exam papers as well, which everyone can gladly have a copy of. It's out there, and I think we have sent out to most people as well. There are videos for try it yourself activities. So this is now where the students on their own, if they're not in class and they want to go over a concept again, maybe when they're away from the class or back at home, so they can scan out QR codes. The video actually goes through an entire example with them, especially the TIYs, the try it yourself activities. And it really assists the students with understanding concepts, especially if you are not there to assist them. Another important thing we are having is lecturer boot camps for content training, also on how to teach the content and exam preparation. So we are looking at having these physical boot camps as well. Shalendra, do you want to add anything in?
No, that's fine.
Okay, thank you. So here is the syllabus for the basic principles of computer programming. It's quite a long name. It's quite a mouthful. It's actually basic principles of computer programming and computer literacy. So the curriculum designer suggested we use maybe an acronym like BPCL, even though there's two P's and there's two C's. So you would see us, if we're sending out content or sharing that with you, we probably use an acronym like BPCL for this programming subject. So we have tried to follow the curriculum document in terms of how we laid out the book, but then you will see there are certain sections where we felt as lecturers, it made more sense for a section to come in earlier or for something to move later on in the book. An example of that would be in topic 3. So in topic 3 in the curriculum document module, we have a module 3 and a module 4 here, visual programming and Python installation. And that's actually all as just one topic 3. So we felt it made more sense to split it up into modules where we covered visual programming, which is Scratch, in its own module, and then Python installation and Turtle in its own module as well. Later on down the line, if you look at topic 5, which is solution development. So we grouped together everything to do with Python programming, which is module 6 to module 11. And we grouped that together under one topic heading, which is solution development with Python. Module 7, which you will see later on, we actually moved and brought in number systems earlier. We felt students need to understand what number systems are before they actually start coding with it or programming with it as well. And then we moved a section like functions later on down in the book in its own module in module 10. We moved down the functions. We also moved files into this module 10. So in our previous slides where we showed you what's the important concepts that need to be reinforced, and that's what we would find now in the modules 6 to 9. That needs to be really understood well by students. Things like what are variables, what's data types, how do we get input, how do we display output, selection control structures, very important concepts, and also the repetition control structures. So a lot of emphasis went into those modules to ensure that students understand those concepts. And then, so because of that, we took out things like string functions, which was earlier on in the curriculum guideline, and we moved it to a section that deals with functions. So that way it made more sense to be grouped together in that manner. The screeners were also really happy with the changes, and they said it also made more sense as well to move them down the list like that. And then the last thing we end off with is arrays and lists. Again, students need to have an overall understanding of what arrays are. Lists is a bit of a repetition or something they learn when they learn Scratch. So by the time they get to lists, they have a better understanding of the concept. And when it comes to list functions, which you will see later on, it's actually nice, simple concepts that's easy for the students to grasp, not as in-depth as arrays can be. So lists here in Python are actually very easy for students to understand. So that's an overview of the syllabus in level 2. So what we would start off with here is topic 1. So topic 1 is on computer hardware and software. So I'll let Shalendra take over from here.
Can you just move it to the next slide? Okay. Right. So in topic 1, so like we said, as you're familiar as well, a lot of the students we get do not have a strong background in IT and computer science. So we've introduced in topic 1, there is part of computer literacy in there. So we did try and use examples that are easy for them to understand, to explain to them exactly what computers are, how they work, the components, and we also keep the language very simple. So as you can see, we mentioned, so here's some of the screenshots that we have in here. Our diagrams are all annotated as well, so the students can easily follow and see exactly like what is a CPU, what are GPIO pins, what is RAM. And remember now, this is now done in the programming book, and this is done in topic 1, and this will be covered practically in the robotics course, but that won't be done so early. That'll be done a lot later. So the programming course now is sort of like giving the students a bit of computer literacy introduction, so they have an idea of what these components are all about. And as a lecturer, what you can also do when you get to the stage, because you will have the device with you, you can also demonstrate that to the students, show it to them, let them see it, let them play with it, and then use a textbook, and then they can follow on a textbook, and they can point to the various components so they have an understanding what the components are, what they look like. So yeah, so that is the area that we looked at in topic 1. And moving forward. Sam, can you move to the next slide?
Yes, I did.
Oh, I think maybe you take over. I actually
Okay.
cannot see it. Yeah.
Yes, so also under topic 1, computer hardware and software, we are also, or the students are also introduced to the Windows commands. So here in level 2, we look at the command prompt and using the different commands that are available. So in our book, we introduce what the Windows command prompt is. We've given them examples as to, or step-by-step tutorial as to how to get to command prompt. And then how to launch command prompt, sorry. Then we moved on and we actually explained to them in a very nice table what all of the various commands are, along with a description of the command. And then we've also given them examples. So we've done it in a very nice, precise way. And so the students can even try out the examples itself, just copy the code as is in the table, and then they can try it out in command prompt. So what we're showing you here on screen is our tables. We've also showing you one of our TIYs, where we go step by step with the student. They're given instructions, and then along the way, we give them screenshots as to what should be happening, what they should be seeing as well, especially in terms of the files. We have, I think, our work files on our lecture guide USB memory sticks. So in there, we actually have work files that the lecturers can copy across, so that way the students can try out the activities and then get the same results that they're seeing in the textbook itself. We also highlight important points like errors. If you type out a command incorrectly, what kind of errors are you expected to see? So that way the student knows exactly what to do if they come across an error as well. So this is topic 1, which is an overview of the hardware and software concepts, and then also the Windows commands. So that was topic 1. Topic 2, very important for all programming students, is to be able to do problem solving. So when it comes to problem solving, we start off with, if you have a look at the learning outcomes, we start off with problem solving process and concepts, basically going through what exactly is problem solving, the different techniques we use to solve problems. And then also very important is this programming development lifecycle. Now, in our book, what we did was we used those color blocking very intentionally. So I'll keep highlighting this as we go along. So here in the program development lifecycle, we use different colors to indicate the different steps. So those are the same techniques that we will then move on to use when it comes to actually creating solutions, as you will see when we're designing our flowcharts, and then also when we move on to programming as well later on. So the colors we used here in this color block is what we carry forward with us throughout the rest of the book. So that way students get used to the concepts, so they know if they see green, they're looking at design. If they see blue, they're looking at actually creating the code, and so on. Very important in topic 2 is for students to understand what IPO charts are. how do you take a problem and break it up into your inputs, your processes, and your outputs. So here as well, in our screenshots, we show you exactly how we give a student a scenario, and then we show them what the IPO chart can look like. And then we always have what we call a let's break it down section. So there's always an explanation for each of the new concepts that are being introduced. So we don't just tell students what IPO charts are and then give them an example and then just move on. We make sure that when they read it a few times, especially, they understand it. And it's something when they're again away from the classroom, away from the lecturer, if they go through it again and they go through the let's break it down, it's just like if a lecturer were to explain it to them. Also in our books, you'll find the symbol which says important. So whenever we find that things should be emphasized to the students, we like to put a little important icon there next to those concepts. So that's problem solving. And then also, we did go one step further because once students know how to design IPO charts, the next step would be to be able to design algorithms. So we went through it in great detail. We explained each of the different programming control structures, from your sequential to your selection to your iteration. We explain how to go from your IPO chart and then go directly into your algorithms. We've shown algorithms in the form of flowcharts, and we've also shown algorithms in the form of pseudocode as well. So, yeah. So we have the syntax. Remember now, when they're designing algorithms, there isn't really syntax when it comes to pseudocode. But here the syntax explains to them exactly in this example how the if-else statement works. And then they see the syntax here, and they will see it again when they program in Scratch, and they will see it again, very importantly, when they are programming in Python as well. So we give them the syntax. We have a let's break it down section so we can explain it in greater detail. Then we have examples. So the examples give them a scenario, and then it breaks it down into the IPO chart. And from the IPO chart, we show them exactly how you go from IPO chart to pseudocode, and from pseudocode to flowchart, or from IPO chart straight to flowchart. So when students see pseudocode together with flowcharts, they start to understand programming a little bit better, especially because the pseudocode they're seeing here is going to help them when it comes to the Python programming. So it becomes very easy to convert pseudocode into the Python programming language. So you will find with all of our examples as well, we do go into detail, and we always follow it again with a let's break it down. So when your students are going through it and going through our books, please always make sure you emphasize to them to read the let's break it down. It's not just text there to skim over. So the let's break it down really helps them to understand the concepts. So that was on solution development. Our next topic 3, which is concepts for programming single board microprocessors or microcontrollers. Okay. So this section was broken up into visual programming and solution development. And then we also broke it up into another module called Python installation on single board microprocessors, which is our Raspberry Pis and so on. So here, module 3, we go into visual programming. Now, before we even go through Scratch, we always emphasize important concepts. Students who are doing programming must always understand exactly what concepts like variables are. If they don't understand that, they don't have the basic understanding, building blocks for programming. So again, you will see us emphasizing these concepts throughout the book. What are variables? What are data types? So here in terms of data types in this module, we just looked at the basic ones, which we find in Scratch. We tell them what the data types are. We have tables where we have a description, and then we also show them examples in that table. Also, in Scratch, we go through the entire interface in great detail in our level 2 book. You will see when it comes to level 3, students do M block. So M block is really similar to Scratch. It's actually more or less the same concepts. The advantages to M block is that you're able to now connect your microcontrollers like Arduino, and you can program in M block. You can also switch between different languages, which again is something you'll see when we get to the level 3 syllabus. So also in our book, we like to explain with enough screenshots, making sure students understand exactly how to program, how to use the interface, where to find the different controls, how it's used. So there's always explanations to go with each of the different concepts that they are learning. So continuing with visual programming, again, here we have our try it yourself activities. So remember I said very important, we look at our color blockings. So we break up our activities into steps, and the steps follow the PDLC. So for example, here, step 1 is to analyze the problem. So students get into that analyzing problems, breaking it up. Always simple when you break it up into your inputs, your processes, and your output. Step number 2 is to design the solution. We've designed with flowcharts. We've also tried to make sure that students use activities that they've created in the previous module, in module 2, and then design programs for the flowcharts and algorithms they created in module 2. So we have designing the solution, then we have implementation of the solution. So implementing in this case is to implement with Scratch. We give them the entire Scratch code, screenshots of the code, so they are able to do this by themselves. Hence, it's the try it yourself activities. So we start off very simple, and then we move on to more complex examples as well. Step number 4 is always to now run the program and test the solution. So you will always see students going step by step, analyzing the problem, designing the solution, creating the code, and then of course testing. Very important concepts in programming. And then we end off module 3 with some integrated solutions. So here we are trying to use all of the programming concepts that we learned: sequential structures, selection, iteration, using multiple sprites, broadcasting. So, and then we are able to create nice activities that students might find exciting. We've done a couple of programs where they've actually created games. So when students love playing games, so when they see that they can build their own games, it really makes programming more fun. That's what I found when the students were introduced to Scratch. So then moving on to module 4. Module 4 is on Python installation and applications. So here we show well as for students and for lecturers alike, how to install Python on your Raspberry Pi. And then also on your PCs as well. So for programming, we don't need to use the Raspberry Pi to teach this course. We just need a normal PC is fine with Python installed, Python IDE. So here we introduce them to the Thonny IDE because this is also something that comes standard or built in with your Raspberry Pi OS. So on that, there's Thonny. Thonny can also be downloaded and used on your PCs, which is what we use often because it's a very, very simple IDE, especially for beginning programmers. There's nothing too complicated about it. It's very simple to create a new file, very simple to run your program, to see your errors, to test your output. What we also do in this module, apart from installations and introducing them to Thonny, is programming with Python's Turtle. So Turtle is used for drawing. We do drawing in Scratch. And so here, when it comes to Turtle, we've shown quite a few examples where we've given them the Scratch code, and then we've also given them the Turtle code as well. So they're able to see exactly how we can go from block-based programming and then convert that in itself into text-based programming with languages like Python. Yes. So it's actually quite nice activities, especially when they are introduced to these programming concepts. Topic 4 is programming tools and utilities. This is all about source control and version control software. So here we can see the learning outcomes. This is a very short section. You wouldn't have seen it when Shalendra explained the core content for level 2. Students need to have a general understanding or basic understanding as to what source control is, what is version control software. So all of these theory concepts, they need to now start having an idea as to what it is. And then it will be emphasized again in level 3. And then they would actually use it practically with an example is with Git. So they actually use it practically in level 4 itself. So they say it now, they introduce to a concept, what is source control? In level 3, then they'll go into a bit more detail as to what is Git, how it's used. And then in level 4 itself is where we actually use Git, and students will be saving their files using things like GitHub and so on. But again, here, mostly theory, mostly to have an overview as to what source control is. Okay, then we move on now to solution development with Python. So Python is basically like half of the syllabus. So programming in Python is very important. It's what you tested on the final examinations. Half the paper would be on Python itself here. So in module 6, we're given an introduction to the Python programming language. We also give you another IDE that we can use, which is PyCharm. Now, there is no, even though the curriculum document says that we can use Thonny or we can use PyCharm or we can use VS Code if we wanted, there is no specific IDE that you have to use. Like with VB programming, you would have to use Visual Studio. So with Python programming, there isn't an IDE that you have to use. You can choose whichever IDE you want to. So here we actually go through the PyCharm IDE. We explain to students how to save files, where to save files, how to create new applications or new projects, and so on. So the PyCharm IDE is a little bit more complex than Thorny. So it really would be up to you as to which IDE you want to use, because it really makes no difference. Your code is the same. You will run your programs and you will get the same output. It's just a question of how you save your files. So this is the PyCharm IDE. Moving on to module 7. So module 7 is where we are introduced to number systems, data types, variables, the different arithmetic operations. We do a little introduction to strings as to what strings are, but when it comes to string functions itself, we move that over to our module 10, which deals with functions. So here, because we're doing simple programs, we're using variables, students need to know how to get input from the user, do some calculations, and display output. So that is why we brought input into this module as well. So you would see in our books, when it comes to number systems, we show them exactly how to convert from one number system to the next. Our examples go step by step, explaining to students what's the process you need to follow. We repeat that so they get a better understanding as to how to solve these problems. And then we give them activities after each section. When it comes to data types, again, we put it in a nice table format so students are able to understand the different data types that we use in Python. So Python isn't like other programming languages like C++ or Java or VB, where you have to declare a variable before you actually use it. In Python, there is no variable declaration. So the variable will take on a data type depending on what it is that you store or what value you store inside the variable. So again, variables are reiterated, even though we introduced it in module 2, it's something they have to go through again. It needs to be reinforced. So again, we explain what variables are and how they are used in programming. Our activities, now that we are programming in Python, so you would find in our try it yourself activities, again, we go step by step with the students, telling them exactly what to do at each step. And then we give them screenshots of what the code should look like, whether they type it out in PyCharm or they type it out in Bunny. And then we also tell them or show them what the outputs are for each of those programs. So whenever they try something out, the result should be as it is shown in their books. So here as well, we have some complex operations and then string operations as well, which is covered in this module. Also in topic 5, to end off with, even though it is a function, students have to understand how to get input from the user. So we explain to them in great detail as to how the input function works, give them examples, and then they can create simple programs where you get input from the user, and based on the input, then you do something. So module 7 is all about data, variables, getting input, displaying output, and it's just sequential programming. That is module 7. Okay, so moving on to module 8, very important concepts. So very important concept here is selection control structures. Students have to understand how these structures work, what are if statements, what are if else statements, Conditional tests, they need to know the different relational operators. Again, they were introduced in module 2, and the process is reinforced again here in module 8. We also go through the logical operators, the and, the or, the not operator. We repeat examples that we used in module 2, where students design the solution, and then now we show them how it's done practically so they can see it. When it comes to selection statements, we cover the if-else, we covered nested if, and then also Python has an if-else chain as well, which is like a nested if statement. So again, try it yourselves. We go again step by step, showing the student exactly how to type out the code, how to run the program, what your results should be. So when we go into greater detail for each, whenever we go through a concept, we give them the syntax of the different structures. Give them syntax. We have a let's break it down section. Then we give them problems. So we have scenarios, and then in those scenarios, we break it down into analyzing the problem. Again, stuff we've seen in Scratch. So with our IPO charts. Then comes the design of the solution using your flow charts. They could also use their pseudocode. Then implementing the solution in Python. So we give them the entire code. It's all typed out. Even in your lecture guides and your CDs, you will find that we've given you all of the programs, electronic copies of the programs as well. So you can download it, and then you can also display it on screen for your students to follow as well. So all of these activities are shown, are given to you on your, with your lecture guides. So again, the last step always to test your solution, and then we have them test with different values and then see that they get the same outputs as shown in the book. So we have activities. We said we have try it yourself activities, which you've seen a lot of. Then we have test yourself activities, which are smaller activities to test a particular concept. So after they do it themselves, then after they follow it step by step, then they do it themselves with the smaller activities. And then at the end of each module, throughout all of the modules, we have summative assessments. So you would see I've just put a couple of screenshots here from module 8, which shows us the types of questions that students could get in an examination, where they analyze code, go through the code, provide output, fill in the blanks, and so on. And then also in terms of programming problems, the kinds of problems that you may actually find in an examination, where there's a long scenario, student is given an IPO chart. That's generally how it goes with programming. We give students a scenario, we give them the IPO chart, and then from there we expect them to be able to now create the programs. So that's an idea as to what will happen in, say, a trial exam or a final exam. Those are the types of questions that we put in the summative. So then we move on to module 9, which is repetition control structures. So again, in this module, in terms of the learning outcomes, students need to know with Python how to use the while repetition control, how to use the for loops, and then nested loops, either with the same loop type or with mixed nested loops. And we also have break, pass, and continue statements, which allow students, or which allows programmers to exit at different points in their code. So they're able to break out of maybe a while loop if a particular scenario has been achieved. So here we explain again, we show them an example of what the while loop actually looks like. our code is annotated. So we show students, very important with Python, is code blocks. So Python will show you a block of code based on indentation. So it isn't like C++ where we would use curly brackets to indicate a particular block of code. So Python does that with indentation. So also here in module 9, if you haven't maybe learned Python or you haven't done Python and you go from languages like VB, so something that's new here is the range function. So we explain it in detail. So with Python, we have where we can specify values like what's your starting, what's your stopping value, how many do you step up by. So you don't always need to have those values in, okay? But you need to be able to indicate what's the stop value so we know how long the loop should run for. So we actually show students an example of how the range function works based on different values that they put into their brackets, what the loop counter values can be. Nested loops are a very difficult concept to understand for level 2 students. So we've tried to give them examples where you can actually see where the nesting comes in, what happens first, and then which steps are repeated inside the loop. So how does the outer loop work? How many times does the inner loop run? And then we explain that with some very nice examples. Also, to understand nested loops, displaying of patterns is a very nice way for students to see how nesting actually works. So how many times the loop runs, or what happens in the inner loop, what happens each time the outer loop counter increments, and so on. So here we have very nice examples when it comes to displaying patterns. And then again, just to reiterate, summative assessments, again, types of questions that you could expect in a theory paper, and then also the types of questions you can expect in a practical exam paper. The next module is module 10, where we put it together with modularization, functions, and then we also brought in files from earlier on. So here we explain to in our book exactly what modularization is, what are functions. Very important here, when it comes to functions, students have to be able to create functions that do not return values. And then we are also creating non-parameter functions. So we're creating very simple functions that just perform a task. You call it, and then it will perform the task that you have set it out for it. So students don't have to know how to pass parameters. They don't need to know how to return values as well. So it's very simple functions. Once we've introduced exactly what functions are, we also again introduce variable scope now, because we now have functions. We have variables created at different parts of the program. Students need to understand what variable scope is. Then we move on to using the math library functions, and then using the built-in string functions as well. So we again show them, if you want to use math functions, you have to import files, and they've already learned how to import when they were back in module 4. So we've given them, we go through examples, we tell them how to run the program again. In terms of string functions, we put again everything inside a nice table, so it's easy for students to see at a glance exactly what the function name is, how the function works, what's the syntax. Then we give them an example which they can copy straight out and into Python or PyCharm or Bunny, whatever the case is, and they can run the program, and then they can see what output they get. So we also have the output column. So it's very short and sweet examples without going into very much detail like we do with other examples. So the last thing we do is we end off with files. So students need to know how to write to a text file. So in PyCharm, when you're writing to text files, automatically it will create the text file for you in your same folder that you are currently working in. So you're able to see when you run the program, did your text file actually, was it actually created and so on. And then if you open up your text file, then you can see exactly what was written to the file, so you know if it worked. Also important is for students to be able to identify errors in their programs, errors when it comes to trying to write to text files and so on. So we show all of that here in this module 10. The last module that we end off with in level 2 is arrays and lists. So this is now data structures. Again, we introduce them to the concepts, make sure they have an understanding as to what lists are, what are arrays, what are dictionaries. So this is where they start building their foundation. So they know, okay, this is an array. What makes it an array? How many values can I store? Same with lists. With Python and lists, you are able to store values of different types. But with arrays, it has to be values of the same data type and so on. So in this module, when it comes to differentiating between lists and arrays, or showing the similarities rather, we put them into little tables under each section. So like, for example, if we want to count the values, then we show them what do you do with lists and then what do you do with arrays. So how is the code different? So there's a lot of similarities in the code. So when students start using arrays more in level 3, they understand the concept a lot better. So in terms of this module, students should have an understanding as to what arrays are. But when it comes to lists, they need to be able to use lists and the list functions that are associated with lists. Again, the list functions are really simple to use. So we've given, again, in the table, explained what the different functions are, what's the syntax, given an example, and then also shown them what the results will be. And again, summative assessments, very important. What we see in the book is the kinds of things that you will be able to see in a test or an exam. So that's in a nutshell. Not sure if it was a nutshell, was the level 2 syllabus. So now I think we can move on to onto the level 3 syllabus. So again, sorry, I just wanted to know if we're taking questions. Are we doing it at the end of the session?
Maybe it'd be a good idea to take a few questions now and just have a pause.
I think maybe let's pause on level 2.
Yeah, just to give you a bit of a break.
Okay.
And then maybe we can do level 3 next week. Yeah.
Yeah. Yeah, looking
So,
at
Shlendra, you
the time.
suggest we do questions now.
Yes, we can do questions now.
Okay. Malane Sateche, please go ahead. You need to unmute yourself. Malane, you've got your hand raised. Okay. Doesn't seem like you want to ask something. Anyone else? If you have a question you'd like to have answered, any queries you want to check on? None so far, Sam.
Okay, that's great. Gang, can you tell me, is Daniel in the audience?
Sorry, who?
Oh, Daniel.
I'm not seeing his name. No. OT.
No.
Is it OT?
Yes.
No, it isn't.
Well,
No, his
Daniel,
name
if
is
you
not.
are, you can raise your hands. Okay, no
Okay.
problem.
Malani has raised his hand again. Yeah, you can go ahead. You just need to unmute yourself and you can pose your question. Malane, we're waiting for you. Your hand is raised. No response.
Okay.
All right, Sam, I think we could, do we want to continue, or what did Shalendra say about carrying this over to next week?
Maybe we can get a consensus from the audience. Should we move level 3 to next week, or do you want me to go over some of the content now?
We need feedback from the audience, so to inform us how to proceed.
Yes.
Somebody could just give us an indication. We're not getting any responses, unfortunately. Yes, Lebogang? Lebogang, your hand is up. Lebogang, please go ahead. Yes, you can go ahead now.
Okay. Can you hear me?
We can hear you. Yes, we hear you. Yes, go ahead.
I actually just wanted to say, I think the organizers have muted us. That's why Malani couldn't be able to comment.
Oh.
But
all right,
I'm of the concept that we should continue with level 3 next week, because if I look at the time,
right,
and the way in which the presenter is taking the time to make sure that we understand the syllabus and how the textbook is going to be used, I think we are just going to try and rush ourselves. So I think it's better if we put level 3 for next week, because really what is being done here is of great importance. Thank you.
All right, thanks. Malani, you say you have a question? You've muted yourself, so you need to unmute. Malane, you need to unmute yourself and you can speak. Yes, Malane, what is your question? We're not hearing you at all. Do you want to post it in the chat? We can pick it up from there. Any other contributions before we decide whether we're going to carry this over to next week? I think Lebogang made a very valid point. Are you all happy for us to continue next week? I think it's been a very in-depth and comprehensive session and presentation by Sam this afternoon, with assistance by Shalendra. And as Lebogang pointed out, we don't want to rush through this. It's very important content, and perhaps we should just continue next. I think it's the 25th, if I'm right. So you need to register for that session as well. Sam, your thoughts? What would you like to do based on what we've heard so far?
Okay, based on the one attendee and
You want
Shalendra.
feedback?
Yeah, I'm fine with postponing to next week, the level 3. As long as like have a nice understanding of level 2, and then next week we can proceed on to level 3, and then also try and bring in other concepts like exams and so on. So I am fine with
that'll
that.
be perfect. All right. Okay, so we'll take it that that is what's going to happen, that introduction to technical programming will be carried over to next week, and then we'll have more time to go through other stuff as well. Thank
Yes.
you to our presenters for a fantastic job this afternoon. Thanks, lecturers, for attending, and we'll pick this up again next week.
Thank you very much, Gan. Thank you guys for attending and for your contributions. And yes, we look forward to seeing you again next week. Thanks again.
Bye-bye, everyone.
Bye. Gan, would we have like a register of some kind to show who attended?
Yeah, we'll get that.
Great, thank you. I would appreciate that.
All right. Okay.
Thank you. Have a good afternoon for the chat next week.
Bye, everyone.
Hey, thank you so much. We will register
Okay.
again. Thank you.
So again, lecturers will just use the same link again to register for next week's session.
Yeah. There's a separate link for that, Sam.
There is. Okay, I haven't. Okay, because the one I had was still for last week and this week.
Yeah, I know. I think I sent it to Shalenda. Was it yesterday?
Oh, okay.
So you'll pick it up from that email. Yeah. All right.
Okay. We'll check in
Okay.
and I'll
We'll chat again.
share. Okay. Thank you.
All
Bye.
right. Okay, bye.
Bye.